Assalamualaikum warahmatullahi wabarakatuh. My name is Nabil Azra Hazib bin Abdul Halim, and today I will present to you the phase change processes on cooling system for the individual assignments of low temperature physics course. So, the objective of this paper is we aims to study and understand the application of phase change processes in the low temperature physics by using the phase change materials. So basically, the phase change process, we know that it is when one state of matter change into another state, such as when solid into liquids or liquid goes into gas and so on. So this phase change process can be applied in the low temperature physics applications. One of the application that use the low temperature physics is the thermal energy storage, which is the technology that use the phase change materials. The phase change materials is used in this technology because it have a unique property in storing and releasing a large amount of thermal energy, which it applies the concept of latent heat of fusion or solidification, where the energy is stored and released without undergoing change in temperature during the phase transition, which make it a good material to control any temperature fluctuation and also be used in the cooling system. So in this paper or in this discussion, we will discuss the cooling ceiling system, which is one of the application that apply the low temperature physics by using the phase change materials. So the in the experiment that use the phase change materials or phase change processes for the cooling ceiling system, we have three important procedure that need to be tested and recorded. So the first one is the cooling capacity measurements. The second one is continuous cooling cycle system measurement, and the last one is the heat load absorption. So basically, the cooling ceiling box is designed with the dimension of 1.6 times 0.8 times 0.2 meter volume, filled with a layer of paraffin-based PCM, which is known as an organic phase change materials, and also with a tube heat exchanger inside the cooling ceiling box. Also, a test chamber with the cooling ceiling box and many other components such as heat loads are built in the same space. So the experiment started with the measurement of a cooling capacity of the system with and without the phase change materials. So for the cooling capacity measurement, there are four different measurement points that were taken for the cooling capacity at 6, 8, 10, and also 12 Kelvin with a coolant flow rate of 5.1 per minute for both cases. The next procedure required the measurement of of this continuous cooling cycle, which this process involved three important parts, which were steady state cooling, discontinuation, and also active cooling process. So firstly, the cooling system was set to reach the steady state conditions for 90 minutes, and the next 90 minutes continued by shutting down the circulating pump and also the cooling source, where only the heat load was switched on in the space in the test chamber. And during this shutting down process, during the discontinuation process, the temperature of the surrounding air will start to increase, and some heat load will be absorbed by the PCM, the phase change material, in the cooling ceiling box. And finally, the last step for the active cooling, both the circulating pump and also the cooling source will switch on until the system reach the initial conditions. And the process also carry out for the cooling system for both cases with and for the cooling system with and without phase change materials. And the last procedure consists of the heat load absorption. This procedure almost similar to the discontinuous cooling cycle that we discussed previously. However, we're only looking at the active cooling parts where we will observe the phase change material regeneration that will occur during the process. So basically, the other parts for the circulating pump and also the cooling source will be off, while the heat loads will be the one that switch on during this process, and it will trigger the phase change material to regenerate, where the coolant will dissipate the stored thermal energy during this regeneration. And after the temperature is dropped and restored, where the cooling is is happening, the active cooling will switch off when this temperature is reaching the certain point, and the phase change material will reabsorb heat load inside the room to prevent overheating. And this process will be repeated in a cycle and monitored, and the result will be recorded. So for the results and discussion of the cooling capacity measurement, as we can see in the graph here, the cooling system when the PCM layer was not present have a higher specific cooling capacity and also a total cooling capacity compared to the system when PCM layer was involved or was present in the cooling ceiling box. Also, we can say that the cooling capacity for the system when PCM layer was used have a 20% lower than the cooling capacity when there is no PCM layer. This is because the PCM or the phase change material have a low thermal conductivity, which leading to this result. And we can also say that the stabilization process for the system when there is no PCM layer was faster compared to when there is the PCM layer. So next, for the discontinuous cooling cycle measurement, we can see here from the graph here, we know that the cooling capacity for the ceiling when there is PCM is lower compared to the ceiling when there is no phase change materials. However, from the graph here, we can see that the cooling ceiling when there is a PCM layer or phase change material has a lower temperature rise compared to cooling ceiling without the phase change materials. So we can conclude from the graph here that the PCM or the phase change material based system can cool the air in the system faster, even though it has a lower cooling capacity than the ceiling when there is no phase change materials. Finally, for the heat load absorption measurement, firstly, we know that when the higher the heat load, the faster and larger the overheating may occur. However, these effects can be solved or be countered by the cyclic regeneration of the phase change material during the active cooling process, where it allows the temperature to reach below the phase change temperature, such as that the stored latent heat energy from the phase change material was removed during this process, so that this situation can be achieved, or this result can be achieved. Also, from the experiment, it proven that the usage of the phase change material in the cooling ceiling system is effective in maintaining the regeneration of the heat storage medium. These results were supported by the comparison graph that was shown here, where where the PCM, the phase material layer, can absorb the heat load in the system and helps to cool the air temperature, which means that the phase material is clearly a good material in providing a cooling ceiling system compared to when there is no phase change material. So, from the experiment and from this paper, we can conclude that the phase change materials play a crucial role in contributing to the low temperature applications, and also there are many other industrial applications that widely use the phase change material for the thermal energy storage systems such as food storage, food packaging, and also air conditioning. This is because the phase change materials have the unique ability that we discussed earlier, which they are able to absorb and store heat during the phase transition for later use. Also, there are many, however, still until today, there are many extensive studies are still going on related to the low temperature applications, since we believe that we can achieve more than what we achieve today. So that's all. So that's all from me. Thank you very much.